Hello, students, and welcome to our lesson on subtracting mixed numbers. So for our do now, we will respond thoughtfully to the prompt about ways to advocate for yourself. So today's topic is advocating for yourself. Our objective today is to subtract mixed numbers. Our essential question will ask, how can I subtract mixed numbers? And how is subtracting mixed numbers like adding mixed numbers? And then we'll also ask, how do I know when my answer, is fully simplified? That's important. So we will watch the video and we will complete the assigned work on subtracting mixed numbers. Always make sure you read all of the directions because there's important information there. Our exit ticket will ask us to describe the steps for converting an improper fraction to a mixed number. And for homework, just finish up any work you have not completed in class and try to do at least 5 problems on your own without help from the video. I know you can do it. I'd love you to show someone at home your notebook in Teams so they can see what you're doing. Some important notes we have coming up. I always remind you that our quizzes in Teams, you have to hit that See Results button when you're finished, and that submits your work to me so you can get credit for all your hard work. When you do these assignments, I want you to make sure that you have your notes next to you when you work. You must bring them to school when you're in school, and you must have them next to you when you're at home. We do our do now and our exit in Teams, but we do our work on our notes. Pause the video often and try to do the problems on your own. The more you can work out teaching yourself to do things without just watching and copying, the better you will learn. And after you've done that, always check your work using the video. So let's get started. Here's our fall picture for today. We don't want you to get behind. Always come for an extra help session. And there's our pumpkin. I love that picture. I think it's so pretty. Photographers call these circles of confusion, and they happen in a low light environment. You get those circles. So our question today is about self-advocacy. Are self-advocates always loud, boisterous, rude, ill-mannered, so they can be heard by everyone? Does self-advocacy require a lot of noise? Or can self-advocacy be done in a quiet and thoughtful way? So think about that and write a sentence or two about that. So here's where we will work on our exit ticket later. We will describe the steps for converting an improper fraction to a mixed number. So let's get started. When we subtract mixed numbers, we have a lot to remember. First, we will find our least common multiple of both denominators, and that is our common denominator. We've done that before. And we will rewrite each fraction using that common denominator. We've done that before as well. Here's where it gets a little different. Here's the new information. If the first fraction is smaller than the second, you need to borrow one whole from the whole number in the first mixed number to increase the fraction. And I'll show you what that means. We'll do that in a minute. Then we subtract the numerators. We've done that before and keep the denominator the same. We'll also subtract the whole numbers, and if necessary, we will simplify. So the new stuff is really this part right here. So I'm going to take us to another page, and we're going to work on some problems. So here we have our blank page. I think I'll use this one with the graph. I think that'll be better for our purposes. So let's start with 5 and 11/12 minus 3 and 9/10. Now, we need to have the same denominator. We have a 12th and a 10th. So what are the multiples of 12? 12, 24, 36, 48, 60. Bingo. 60 is also a multiple of 10. So that will be our new denominator. So we'll rewrite the problem using our new denominator of 60, but we also have these whole numbers. So we've got 5 and some amount of 60ths minus 3 and again some number of 60ths. Well, how do we get from 12 to 60? We multiply by 5. So we're going to multiply the numerator by 5. 11 times 5 is 55. How do we get from 10 to 60? Well, we multiply by 6. 9 times 6 is 54. Let me fix that. Okay, 9 times 6 is 54. So that'll be 54 60ths. Now, let's subtract the whole numbers and we'll subtract the fractions. So 5 take away 3 equals 2. And our denominator is 60ths. 55 minus 54 is 1. And that's a final answer that cannot be simplified. Now, let's try one that has that extra step we talked about. Let's change our color. And we'll start with 6 2/3 minus 3 4/5. So let's figure out what our denominator will be. Let's list the multiples of 3. 3, 6, 9. We're looking for one that is also a multiple of 5. 12, 15. There we have it. 15 is a multiple of 3 and it's a multiple of 5. So our new denominator will be 15. So we will have 6 and some number of 15ths minus 3 and some number of 15ths. How many 15ths will be in our numerator? So, well, 3 goes into 15 5 times. So if 3 times 5 is 15, we multiply 2 times 5, and that gives us a new numerator of 10. 5 times 3 is 15, so we'll multiply our numerator by 3, and 4 times 3 is 12. So what we have now is 6 and 10/15 minus 3 and 12/15. Well, this is where we run into that problem where this numerator of 12 is greater than this numerator of 10. So we need to borrow one whole from the 6. Now let's think about what fractions are for a minute. Let's make a little sidebar down here. If we're talking about 15ths, then one whole would be 15 over 15. That's one whole. In fact, if we have 6 wholes, that would be one group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups of 15 over 15. That's what this equals 6. So we're going to borrow one group because we need to add 15 over 15 to right here to 10 over 15. And remember, we keep the denominator when we add. So 15 plus 10 is 25/15. But now, instead of having 1, 2, 3, 4, 5, 6 holes, okay, we're only going to have 5 because we borrowed this one and turned it into 15 over 15. So this first number right here, instead of 6 and 10/15, we're going to rewrite it as 5 and 25/15. Okay? Now, the whole idea, why did we do that? Because we have a 10 in the numerator on the left and a 12 in the numerator on the right. We cannot take 12 away from 10 in this situation. We need to have this number to be larger, and we do that by converting so that we have a larger number in the numerator. So we'll rewrite this entire problem as 5 and 25/15 minus 3 and 12/15. And that will equal 5 minus 3 is 2, and 25 minus 12 is 13. 13, and keep our same denominator of 15ths. So that was one of the more complicated ones. So let's go back to our work. And let's try to do some of these problems together. So first problem, 3 and 5/8 minus 1 and 1/2. Well, we can work with this denominator of 8 because it is a multiple of 2. So our first fraction won't change. We've got 3 and 5/8 minus 1. And how many eighths will it be? Well, 2 goes into 8 4 times. I multiply 1 times 4, and I get 4. So we're all ready to subtract. 3 minus 1 is 2. We have a denominator of eighths. 5 minus 4 is 1. 2 and 1/8. Let's do the next one. We need a multiple of 3 and 4. So multiples of 3 are 3, 6, 9, 12. Well, 12 we know is also a multiple of 4. So we can work with the 12ths. So we're going to set up our problem. 2 and something 12ths minus 1 and something 12ths. So 3 goes into 12 4 times. So 3 times 4 is 12. We multiply the numerator by 4. 2 times 4 is 8. Now 4 goes into 12 3 times. So 4 times 3 is 12. 1 times 3 is 3. Now let's look at our numerators. Can we subtract 3 from 8? We can. So let's start with the whole numbers. 2 minus 1 is 1. Our denominator is 12ths. 8 minus 3 is 5. Okay, and that's the final answer. Here, let's look at our multiples of 8. We need a multiple of 8 that's also a multiple of 5. So multiples of 8 are 8, 16, 24, 32, 40, and that is also a multiple of 5. So let's rewrite this. 4 and some number of 40ths minus 2 and some number of 40ths. So 8 times 5 gives me that 40. 7 times 5, remember, multiply the numerator and denominator by the same factor, and 7 times 5 is 35. And 5 times 8 is 40. 3 times 8 is 24. Can I subtract? Is 24 smaller than 35? Yes, it is. We'll start with our whole numbers. 4 take away 2 is 2. Our denominator is 40ths. 35 minus 24 is 11. And that cannot be simplified any further. So that's a final answer. And let's work on number 4. Well, we know already from problem number 2 that if we have a denominator of 3 and 4, that our new denominator will be 12. So let's rewrite this with denominators of 12. So this would be 3 and some number of twelfths minus 1 and some number of twelfths. 3 goes into 12 4 times, so we'll multiply 2 times 4 to get 8. 4 times 3 is 12, so we'll multiply 2 times 3 to get 6. And is 6 smaller than 8? It is. We can go ahead and subtract. 3 take away 1 is 2. We're working in twelfths. 8 take away 6 is 2. Now, we can simplify this a little bit more. So we can divide 2 by 2, and we can divide 12 by 2. And when we do that, we will have 2 and 1/6. And that is our final simplified answer. Number 5, we already did number 5. We did that on this page here. That was 2 and 1/60. So let's just write that down. So let's work on number 6. I think we did that one as well. Let's see, 6 and 2/3. Yep, we did number 6 as well, and we have a final answer of 2 and 13/15. So we'll just put the answer. Okay, let's work on number 7. 10 is a multiple of 5, so 10 can be our new denominator. So that means this will not change, at least for now. So we have 4 and 9/10 minus 2, and 5 times 2 is 10, 1 times 2 is 2. And can we subtract 2 from 9? We can. So 4 take away 2, our whole number is 2. 9 take away 2 is 7. Our denominator is tenths, and we cannot reduce that any further. The last problem on this page. Let's see, multiples of 6 are 6, 12, 18, 24, 30, and that is also a multiple of 5. So we can go with 30 as our new denominator. So 12, and how many 30ths? 5 times 6 is 30, 4 times 6 is 24. Minus 3, and again, how many 30ths? 6 times 5 is 30, 5 times 5 is 25. This is one of those problems where we will need to borrow from this 12. So to borrow, we're going to borrow one group of 30 over 30. So now the 12 will borrow 1, it will become an 11. And now we're going to add 30 over 30 to this 24 over 30, which will give us 54 30ths. So this will be, the first fraction will be 11 and 54 30ths minus 3 and 25 30ths, which will equal 11 take away 3 is 8, and 54 minus 25 is 29. 8 and 29 30ths, that's a final answer. So why don't you go ahead and start the next 4. We'll do them in groups of 4. Let's see how many there are. 7, we'll do 4, then 3, then 4, then 3. So that you start the first 4, pause the video, and then come back and you can check with me how you did. Please do that. Try them on your own. Okay, how did we do? Are we ready to move on? So let's see what we have. We have a 3 and a 5. Multiples of 3 are 3, 6, 9, 12, 15. Well, 15 is also a multiple of 5. So we will have 5 and 3 times 5 is 15. 2 times 5 is 10. 5 and 10/15 minus 3. And 5 times 3 is 15. 3 times 3 is 9. Can we subtract 9 from 10? We can. So 5 take away 3 is 2. 10 take away 9 is 1/15. And that's our final answer. Number 2. Let's see. 5, 10. Our new denominator will be 10. So we'll have 10, and how many tenths? Well, 5 times 2 is 10. 3 times 2 is 6. Minus 4, and how many tenths? Well, 2 times 5 is 10, so 1 times 5 is 5. Can we subtract? Yes, we can. The numerator on the right is smaller than the numerator on the left. So first 10 minus 4 equals 6. Working in tenths, 6 minus 5 is 1 for the final answer of 6 1/10. Number 3. 6 is a multiple of 2, so the first fraction won't change. 9 and 5, 6, minus 3. And how many 6? Well, 2 times 3 is 6. 1 times 3 is 3. And it appears that we can subtract. So 9 minus 3 is 6. 5 minus 3 is 2, 6. We can reduce that to 6. 2 goes into itself 1 time and into 6 3 times. So 6 1/3 is our final answer. And number 4, we're going to have to find a new denominator for that. So 7 multiples of 7, 7, 14. Well, any even number is a multiple of 2. So 14 will be our new denominator. So we will have 4. 7 times 2 is 14. 6 times 2 is 12. Minus 2. And let's see how many 14ths. 2 times 7 is 14. 1 times 7 is 7. So 4 take away 2 is 2. 12 minus 7 is 5. And that's the final answer, 2 5/14. All right, go ahead and try numbers 5, 6, and 7, and then come back. Okay, let's look at multiples of 10 that might be also multiples of 3. And I think we will go with 10, 20, 30 is a multiple of 3. So we've got some converting to do. So 5 and 3 times 10 is 30. 2 times 10 is 20. 5 and 20 30ths minus 3. And 10 times 3 is 30. 1 times 3 is 3. So 5 minus 3 is 2. Our denominator is 30ths. 20 minus 3 is 17. 2 and 17/30ths. Now the next one, I think we're going to do a bit of work on this one. So let's look at multiples of 8 and 3. So we have 8, 16, 24. Well, 24 is a multiple of 3. 8 times 3 is 24. So we'll go with the 24. So we're going to start with 3, and 8 times 3 is 24. 3 times 3 is 9, minus 1. And 3 times 8 is 24. 2 times 8 is 16. Now, we're going to have to rewrite this problem because we have a larger number here being subtracted from the smaller number here. So we're going to borrow from the 3. So we're going to borrow one group of 24 24ths and add it to our 9 over 24ths, 9 24ths, to give us 33 24ths. And that means this will be one less. That'll be a 2. So let's rewrite that as 2 and 33 24ths minus 1 and 16 24ths. 2 minus 1 give us 1. Our denominator is 24ths. 33 minus 16 is 17. And our final answer will be 1 and 17 24ths. So for number 7, we are dealing with 8ths and 1/2. Well, 8 is a multiple of 2, so our first fraction for now is not going to change. 7 and 3/8 minus 2. Now, 2 times 4 is 8. 1 times 4 is 4. But again, we're going to have to borrow because we're not going to subtract 4 from 3. So when we borrow one group of 8 over 8 from 7 and 3/8, 8/8 plus 3/8 equals 11/8. So the 7 will become a 6. So that will be 6 and 11/8 minus 2 and 4/8. 6 minus 2 is 4. We're working with 8ths. 11 minus 4 is 7. So we have a final answer of 4 and 7/8. So let's go back up to the top of the page. And let's do number 8, 9, 10, and 11. So pause the video and try to do 8, 9, 10, and 11 on your own. Okay, so let's get ready. So if we have a 3 and a 2, we know our common denominator will be 6. So we'll rewrite this in 6. So how many 6? Well, 3 times 2 is 6. 2 times 2 is 4. Minus 1, and how many 6? Well, 2 times 3 is 6. 1 times 3 is 3. So 5 minus 1 is 4. We're working in 6. 4 minus 3 is 1. And our final answer, 4 and 1/6. Number 9. 8 is a multiple of 4, so we don't need to change that first fraction just yet. So we'll keep it at 5 and 7/8 minus 4. Now, 4 times 2 is 8. 3 times 2 is 6. And now, 5 minus 4 is 1. We're working with 8ths. 7 minus 6 is 1. So 1 and 1/8 is a final answer. Number 10. Just like before, if we're working with 3 and a 4, that means we need a common denominator of 12 because that is the least common multiple of 3 and 4. So 3 times 4 gets me to that 12. 2 times 4 is 8. That gives me my new numerator. Minus 4. 4 and how many 12ths? Well, 4 times 3 gives me 12. 1 times 3 is 3. Now, 7 take away 4 gives us 3. We're working in 12ths. 8 minus 3 is 5. So 3 and 5/12 is a final answer. And let's do number 11. If we have a denominator of 5 and a 4, let's look at the multiples of 5. 5, 10, 15, 20. That 20 is going to be our least common multiple because it is also a multiple of 4. So we'll work with 20ths. So 2 and how many 20ths? 5 times 4 is 20. That means 2 times 4 is 8. Minus 1. Again, working in 20ths. 4 times 5 is 20. 1 times 5 is 5. So we can take 5 away from 8, no problem. So we'll start with the whole number. 2 minus 1 is 1. Working in 20ths, 8 minus 5 is 3. And that is already simplified. So why don't you do the last 3 problems on this page and then come back and we'll see how you did. Okay, let's check out the rest of the problems. We have a denominator, of 12 and 2. Well, 12 is a multiple of 2, so we can go with 12ths as our denominator. So our first fraction stays the same, 4 and 5 twelfths, minus 2 and some number of twelfths. Well, 2 times 6 is 12. So we multiply the numerator by 6, which is 6. But we've got this issue now where we've got 5 take away 6, and we don't want that. We need a larger value in this numerator in order to make the subtraction work. So I'm going to take 1 whole from the 4, and 1 whole, when we're talking about twelfths, is 12 over 12. So we're going to do 12 twelfths plus 5 twelfths, which will equal 17 twelfths. So we're going to rewrite, again, the first fraction. We're going to take 1 away from the 4, make it a 3 and 17 twelfths, minus 2 and 6 twelfths. And 3 minus 2 is 1, working in twelfths. 17 minus 6 is 11. Final answer, 1 and 11 twelfths. So again, if we have a 10 and a 3, this is like problem 5. We're going to need a denominator of 30. So we'll rewrite the first fraction as 1 and how many 30ths? If 10 times 3 is 30, we multiply 9 times 3 for 27. Minus 2/3. We don't have a whole number here. There's no whole number there. So we just have our 30ths. 3 times 10 is 30. 2 times 10 is 20. So 1 take away nothing is still 1. Think of it as an invisible 0 there. Working in 30ths, and 27 minus 20 is 7, and 1 7/30 is our final answer. And again, just like above, if we have denominators of 10 and 3, then our least common multiple is 30. So the first fraction, 3 times 10 is 30, so 1 times 10 is 10. 8 and 10/30 minus 1 and 10 times 3 is 30, so 7 times 3 is 21. And we're going to have to do a rewrite because we cannot take 21 away from 10. So we're going to borrow a 1 from the 8. And we're going to add one group of 30 over 30 to 10 over 30, which will give us 40 over 30. So that's our first fraction. And when we take 1 away from here, the 8 becomes a 7. So 7 and 40/30 minus 1 and 21/30. I'll have to write down here, equals 7, take away 1 is 6, working in 30ths, 40 minus 21 is 19, and that should be a final answer. We can't simplify any further. So let's move on to our error analysis. How did you do with this? Okay. Now we've got our error analysis. These are my favorite ones. So we're going to identify and correct each answer. So when we look at the first problem, it looks like they subtracted the denominators to get this new denominator. So the problem is they subtracted the denominators. We're not supposed to do that. So to do this correctly, we can use 6 as the denominator. 2 and 3, 6, minus 1. And 3 times 2 is 6, 1 times 2 is 2, which will give us 2 minus 1 is 1, and 3 minus 2 is 1, 1 and 1, 6. Number 2. It looks like the whole numbers were subtracted incorrectly. They did 2 minus 2, and then they got 1. So that's the problem. So whole numbers subtracted incorrectly. So let's do this problem correctly. We have 2 and 5/4 minus 2 and 3/4. So our new denominator will be 20. So 5 times 4 is 20. 4 times 4 is 16. They got that part right. Minus 2 and 15/20. Okay, 2 minus 2 is 0. We don't need to write that 0. 16 minus 15 is 1/20. And that's the entire answer. Let's do number 3 and 4. So let's look at number 3. It looks like they subtracted the denominators and they reversed them. So they reversed, no reason to do that, and subtracted denominators. Okay, so what should this be? So if we have a 3 and a 5 as denominators, our new denominator will be 15. So 6 and 3 times 5 is 15. 2 times 5 is 10. 6 and 10/15 minus 3. Again, working in 15ths. 5 times 3 is 15. 1 times 3 is 3. Minus 3 and 3/15. 6 minus 3 is 3. We're working in 15ths. 10 minus 3 is 7. 3 and 7/15. So let's go on to number 4 and 5. So number 4, it looks like they subtracted the denominators. We're not supposed to do that. So they subtracted the denominators. So 4 and 7/10 minus 2 and 5/10. 4 minus 2 is 2. Our denominator is 10ths. 7 minus 5 is 2. We can simplify that to 2. 2 goes into itself 1 time. 2 goes into 10 5 times to 2 and 1/5. And then we'll do number 5. So it looks, number 5, the numerator was not rewritten. They changed the denominator. They did not rewrite the numerator. So all the steps are incorrect. So did not rewrite numerator. So let's do this. 4 1/2 minus 4/5. So we're going with a denominator of tenths. So it will be 4 and 2 times 5 is 10. 1 times 5 is 5. 4 5/10 minus 5 times 2 is 10. 4 times 2 is 8. Now we're going to have to borrow from the 4. So we're going to have 10 over 10 plus 5 over 10, which will give us 15 over 10. So when we rewrite this, this will become a 3. 3 15/10 minus 8/10. 3 minus 0 is 3. We're working in tenths. 15 minus 8 is 7. So 3 7/10 is our final answer. And we're getting near the end. So problem 6. Take a look at that. See if you can figure out what they did wrong. It looks like the whole numbers were subtracted incorrectly. I think that's what's going on there. So, because we have 4 minus 2 and they put 1. So the whole numbers were subtracted incorrectly. So let's see if they did the conversions right. 2 times 5 is 10. 1 times 5 is 5. So this first one seems okay. 5 times 2 is 10. That's okay. And 2 times 2 is 4. So it looks like, we're going to cross that out. It looks like they rewrote correctly. Now let's do the subtraction. 4 minus 2 is 2. We're working in tenths. 5 minus 4 is 1. 2 1/10 is our final answer. So number 7, I think the problem is this numerator. Numerator is incorrect. So let's rewrite it. So we're going with a new denominator of 20ths, and this is our problem. So 3 and how many 20ths? Well, 4 times 5 is 20. 1 times 5 is 5. Minus 1 3/5. So how many 20ths will that be? Well, 5 times 4 is 20. 3 times 4 is 12. So we're going to need to borrow. We make this a 2, and we're going to add 20 to the top. So that will be 2 25 over 20 minus 1 12/20. 2 minus 1 is 1. We're working in 20ths. 25 minus 12 is 13. 1 13/20. Last 3 problems. So number 8. It looks to me that if 2 times 6 is 12, then this should be 1 times 6, which will be 6. So the numerator is incorrect. So let's rewrite that. 5 1/2, if we're going to write it as 12ths, 5 and how many 12ths? Well, 2 times 6 is 12. 1 times 6 is 6. minus 3 and 1/12, and it's all ready to subtract. 5 minus 3 is 2. We're working in twelfths. 6 minus 1 is 5, and that's a final answer. Number 9. Let's take a look at it. I think that they did not subtract the whole numbers. 3 minus 2, there should be a 1 here. So they did not subtract the whole numbers. So I agree with eighths. And it should be 3 2/8 because 4 times 2 is 8, 1 times 2 is 2. So this part is correct. We'll rewrite that. 3 2/8 minus 2 1/8. Now let's do our subtraction correctly. 3 minus 2 is 1. We're working in eighths. And 2 minus 1 is 1, which will give us an answer of 1 1/8. Last problem. So what do you think is going on there, students? It looks like they did not rewrite the numerator. They changed the denominator, but they did not rewrite the numerator. So they did not rewrite the numerator. So let's figure this out. If we have 8 2/3, well, it looks like our denominator of 6 is fine. So that would be 8 and how many 6? 3 times 2 is 6. 2 times 2 is 4. Minus 1 and 1, 6. 8 minus 1 is 7. We're working in 6. 4 minus 1 is 3. And we know that 3 goes into itself once, goes into 6 2 times, which equals 7 1/2 as our final simplified answer. So let's go back to our exit question. So the exit question says to please describe the steps for converting an improper fraction to a mixed number. So we have to find the least common multiple. Oops, I need some color. Least common multiple, and that is our new denominator. We need to rewrite each fraction. We need to, if the first fraction is smaller, we need to borrow one whole. And then we just need to convert. That's all they're really asking about. And then we just go on and subtract. So this will get us there. So that's it. You've worked hard. I'm super proud of everything that you've been doing. You're becoming math superstars. I know it's a lot of work, but I also know that the more you do, the better you'll get at it and the easier it will get. So keep up the good work and you'll be great.